So, good morning, good afternoon, good evening. Take your timing according to yourself. I'm Ansi Sarkar, and now I'm going to teach you signal and system for this semester. So, being a ECE student, it's one of the main subject of your this semester, and I can say you that it's a little bit into tougher side, but you can handle it if you will study it on a proper and regular manner. So, let's dive into the syllabus discussion first. So as you can see, we are having this this 5 modules in our whole syllabus. So if we will see what's there in our first module, it's very basic. So what is signal and what is signal system and the daily uses in our life and different branches of engineering that deals with signal system. Basically, after that, the main thing starts: energy and power signal, a continuous and discrete signal. And here you can see continuous and discrete signal in two types: time as well as an amplitude. And then we will learn about the linearity property, additivity, homogeneity, shift variance, then stability, then reliability, and all this. So mainly we are going to study here energy and power signal, continuous and discrete signal. So continuous and discrete time signal as well as amplitude signal. So after that we are having module 2. There we will be studying linear shift invariant system. And what is this? Impulse response and step response. Convolution, input output behavior with a periodic convergent inputs, characterization of causality and stability of linear shift invariant system. System representing through differential equations. Basically, in module 2, we will be learning about different types of invariant systems and then their characteristics and how they shifting. Here we will be study about the linearity, and then here in second module we will be studying about the linear shifting and all, and then how the system gets through the differential equations and all. And after that, when we move to the third module, here we will be just studying periodic and semi periodic inputs to an LSI system. Okay, linear. So after that we will be studying with basic things: Fourier series, Fourier transform. And I'm telling you, this module 3 is going to be very, very much like from the tougher side. From my end, it's one of the most toughest module after anything. Means like this is the most difficult ones. So when you will go through this, you will have to learn Fourier series, Fourier transform, and their effects in it, and then means like completely the Fourier domain you have to complete over here. And once you get this Fourier, it will be easier for you to learn the rest of the thing, because this is going to be the base of the whole syllabus of this Fourier transformation, Laplace transformation, and Z transformation. So this module is going to be very, very important. So don't you dare to skip at least module 3, and don't you dare to skip anything, because all the things which the order I'm going to follow are going to be the prerequisite of the previous lectures. You need to learn today's lecture, and then you have to go to the next lecture, otherwise you will miss the flow of the syllabus. Then you can't grab it properly. So I think it's very clear here what you are going to learn. And then here you have to learn about discrete time Fourier transform, discrete Fourier transform, and Percival's theorem and all everything. And then in fourth module, you will be learning about the Fourier transform, Laplace transform, and Z transform. Okay. And then if I move further, here you are going to learn the Laplace transform notion of eigenfunction of LSI system, a basic of eigenfunctions, region of convergence, poles and zeros of system, solution to differential equation, and system behavior using Laplace transform. So after Fourier, then we will be moving to Laplace, because quite a difference is there in Fourier and Laplace. What Fourier series can solve, it can't means like solve, it can be betterly solved by Laplace. So here we will be learning with the Laplace, and then we have to cover the Z transform as well. Then at the last module, and means like Actively, I'm telling you, this module is not too much difficult, but you have to take it seriously as well. And here we are going to learn the main thing, sampling theorems. Though I am telling you that the theorems are like much, if you will grab it once, you can just feel the fact. It's a very amazing thing to learn. Then after this, let's dive into module 1. Here today I will be teaching you with some basic terminologies. Very, very basic. So once I tell you about the subject signal system, the first word that comes to your mind is signal. So what is the signal basically? The signal is basically a physical quantity that varies with one or more independent variables. So here if you will see this physical quantity, here you can see any physical quantity that varies with time, and or you can say more independent variables. And after that you can see here how we denote a signal. If we denote a signal like this way, f within bracket x1 comma x2 up to xn, there you can find out that these are the independent variables, and this is the dependent variable signal. This signal is going to be the dependent variable, and this x1 x2 xn is going to be independent variable. Suppose let's take an example of AC and DC. So what do you think, AC is a signal or DC? So when you can see that AC is basically transforming itself according to the time, then it's called as a signal. But DC doesn't do it. So AC is a signal, but DC doesn't give any kind of signal. So here is the beautiful definition of signal comes here, and where you can define that physical quantities that varies with one or more independent variable is called as signal. So, what is signal dependent on? Classifies it into more two means like categories. Firstly, single variable signal. What is single variable signal? Where the signal depends only on one variable, not on much. Here you can see that f depends on x, and if I will see f is a signal that x might be a distance or anything, and here when we will see that g depends on t, so t is time. So this is a single dependent variable. Okay, only one thing. But in case of multivariable signals, here the signal depends on many factors, like many particular time or many particular variables, x1 x2 and all. So this is the definition of signal. Hope it is clear to you. Let me move on to the next topic, system. Signal and system. You can see the first word signal has been defined over here, and next word system comes here. And when you will see that this word system comes here, it has a particular proper definition. What does it tells you? It is basically defined as the process in which input signals are transformed by the system or cause the system to respond in the same way, resulting in other signal as output. So let's take a very funny example. System is something on which like you rely upon. Suppose the system takes an input signal. This college we study. Let's say we all are engineers. So we study in a particular engineering college. And when we come to engineering college, we started living like the way our friends, our college used to teach us to live, because it's a system. So here we can see that input signal are transformed by the system and cause the system to respond in the same way, resulting in the other signal as output. So you are a different person before becoming an engineer, and once you get admission in an engineering college, you become a complete different person because you are into that system. So here is just a funny example that I have taken. So you can see that system is here, and you take a input signal excitement, and there you get a output signal response. And mind one thing, even if you are changing your nature, means doesn't mean that you are changing yourself completely. So that is same for the input signal as well. When you are taking an input signal, an output signal, that is giving, you are the same person after all, so your dependency factor doesn't change. And here in signal as well, it will depend on the same variable, means like that when there is an input signal that is depending on time, after it comes to the system, it will not change into that, it will depends on some different time zone, it will depends on the same variable of time, and the output is going to be the same variable. Okay, so after this, analysis problem and synthesis problem. What is this? Basically, in signal system, when we will study, we will be coming across two different problems. One is analytical problems and one is synthesis problems. Where what is analytical problem? And it's, to be very simply telling you, it's nothing but where an input signal will be given to you and system will be given to you, but you have to find out the output. Okay, and but in case of synthesis problem, input is given to you, output is given to you, and you have to find out what the system is particularly doing. So after all this stuff, I think you need to learn what is the importance of signal and system. So let's dive in. So before I can say you what is the importance of signal and system, do you know that in our regular life, everything that's happening with or related with electronics are indirectly related to signal and system? Because without signal processing or anything like that, we can't even see a TV. So signal and system is a core thing, or you can say the pillar of any communication system. So let's tell me one thing. What is the basic day-to-day life example that you can find in your daily life in signal system, related to signal system, in the comments below? So let me tell you what are the basic importance of signal system. First is in biomedical, it is used, and then in speech processing, like the audio I'm telling you, this is also a form of signal, it's coming. So an audio video equipments, and then you can say in communication, communication is means like too much stars, because in this third semester you're going to learn signal system, that is going to be the pillar of your communication, and then after this in fourth semester you are going to learn analog communication. Then after this you are going to be learning power electronics, image processing, geology, and as well as astronomy. Okay, these are the basic importance of signal system. If you have any interest about anything about this eight pointers, you can tell me in the comment box, and I can give a detailed video how the signal system is used in that particular zona. So without wasting much time, let me move on to the basic things of the signal and system. So signal and system. Here you can see signal and system is there. So signal can be of two types further, continuous and discrete. Okay, so now continuous can be of like time continuous signal and amplitude continuous signal, and same with the discrete as well, continuous and discrete. And what is this basically? Continuous signal basically called as analog signal, and discrete signal is basically our digital signal, where continuous curve is given to the continuous signal, and discrete has a like pulse time for a particular time. Let me go with the definition and make it clear to you. If I will see or show you the definition, continuous time signal is basically specified for every value of time, every value of time. Okay, whereas the discrete time signal is specified for discrete time interval. Okay, and when I will tell you that every value is important, then in continuous you can see that from certain time, this is t naught. Okay, and here this is t2. Okay, and this is t minus 2. So before the time, this is the initial time. Let me show you something. This is the initial time. Okay, this is time after 2 seconds. Okay, and this is time before the initial time. Okay, so here you can see the curve where it is like in growing after a, and then it's again decreasing here. So here this is a continuous time signal. And if I will tell you how does it matters in a system, see, here we take a RT and then continuous time system, and then you will get XT. The thing which I have told you, this T factor doesn't change, right? So this is what I want to tell you over here, that the variables are going to be same throughout any kind of system. Okay. And then if I will take, means like tell you one thing more, let me now teach you what is discrete time signal. So in discrete time signal, functionally we can say these are the impulses, or you can say the pulses: 0, 1, 2, 3, 1, 2. Okay, so these are the integers basically lying for the xn. Why we are not taking, tell me? In this case we have taken as xt, that is our dependent variable, and t as our independent variable. But this time when we are talking about discrete time signal, we are not taking t as our independent one. Why? We are taking n, means like instead of t, because it's about the discrete time signal. When we will see about the discrete time signal, it talks about a particular time. And even if we will tell that this is x n t by t, if we will divide each other, like here I'm showing you, like if I take this is nt, okay, for any particular times, okay, and then this discrete one is going to be nt as well, nt as well. And here if we will do like x nt by nt, okay, then this deducts tt here. That's why we are taking just only n as the independent variable. Okay, I hope it's clear. So here you can see the impulses in 0, 1, 2 and 0, 1, 2 respectively. Okay, here the thing is what? Again, the same sort of thing, n over here, and discrete time signal. Nothing much over here. So let me take you example, which is very basic to learn. See, here you can see a discrete time signal. And here is a question that I have taken, that how to represent signal in the form of like this way. So this is what you have been given. Okay, this is given question, that how will you represent this. So this is the way of representation. Here you can see xn versus n, and here you can see at initial stage 0 there is an amplitude of 1, 1, 2 and whatever is there. So how will you write it? You have to take a like xn is equals to, you have to just write 1 to the amplitude over here. But how will you get to know that the 0 is not lying at point 0 only, means like for this integer? Then you have to show that the amplitude over there at the initial time was already 1. So here you can say that xn where n is equals to 0. This is how you represent a complete signal. Hope I'm clear with this complete slide, and you will get all these notes in the description after completion of the whole chapter. So stay connected with me for that. So let me move on to the next topic. Next topic is addition of CTS, continuous time signal, and multiplication of CTS. These are the basic things you have to learn. So today I will be going through very basic things. So let me take you addition. So for the addition, I'm taking two signals. Okay, let's say first signal. First signal tells me this is the first signal, that is x1t. Okay, and second signal is x2t. Okay, and then here we will be taking x1t here, and this is our x2t. This is our x2t. Okay, so I'm plotting my, means like I'm just taking a random example without thinking much. Think. Okay. See, this is a continuous signal, so I'm drawing it in a continuous manner. This. Okay. And then, okay. So this is our first signal where you can see the amplitude of each after each and every time interval. Okay. You can see the amplitudes. Here amplitudes have been also marked. So this is our time signal. So next I will be taking another one. Okay. So here we can go for like let me take one. So okay. You can see it very clearly, right? So this is our x1 and this is our x2 individually. And then after that, we will be calculating x3. That is going to be our summation of x1 and x2. So how we will like sum up two signals? That's what you have to learn over here. Okay. So for that reason, I will be taking like, okay, here. See, so I'm telling what this is x3. X3 is going to be our x3t is going to be our x1t plus x2t. This is our the third signal. Okay. So let me take the third signal, please. Okay, our x3t. Okay. So how we will do it? Let's take. From here, you can see that between the time interval of t, when t lies between, see here, this is our zero, right? This is our zero. Okay. When the t lies between basically -2 to -1, it is what? It is then only amplitude having 1. Okay. So if x1t is going to be our 1 and x2t is also going to be 1, then x3t is definitely going to be our addition of this 2. That means 2. How it is, how am I telling? Let me figure it out. Let's take from one side, right? So I will be taking minus, the t lies between -3t and 2. Okay. For x1 it is x1t is having 0 amplitude, or means like 0 signal. Okay. But x2t is having amplitude 1. Means, okay. Then x3t is going to be addition of both of them. That is going to be what? That is going to be our 1. Okay. And then after that, when you will take from -2 to -1. Okay. T lies between -2 to -1. There you can see that x1t is our 1. Okay. And x2t is also 1. Okay. Then what is going to be the x3t? X3t is obviously going to be 2. Okay. And then from -1 to 0. Okay. X1 is going to be what? X1 is going to be our 2, right? 2. And here you can see that x2t is going to be our 0. Then what is going to be x3t? Obviously 2. Okay. Here it is 2. And when it comes to 0 to 1, 0 to 1. Okay. X1t is 3. My goodness. 3. And x2t is going to be our 1. Okay. Then obviously x3t is going to be 4. And here you go with 1. Okay. X1t is going to be our x1t is 1. X2t is going to be 2. Then x3t is 3. And then here you can see last one. If the time lies between 2 to 3, then x1t is 1, but x2t is not having any signal, that means 0. And here we comes with our final x3t, that is 1. And by this way, you can see the plottings, right? Here you can see x3t, 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 x3t in different time intervals. By this way, you can plot like the whole sort of thing. This is the way you can plot. Okay. So for plotting, how will you plot then? It's very easy, I think, for now to plot anything. Let me take the into plotting. Let's see. For the first plotting, -3 to -2, when time lies between this, the x3t is what? 1. So obviously 1 over here. Okay. And then when you can see -2 to -1, the thing is what? It is 2. 2, right? So this is 2. Yes, 2 over here. And then it comes to -1 to 0. It is 2 again. So just I will just drop over here. Okay, done. And then you can see from 0 to 1 it is 4, certainly. So here it comes 4. And then after that, when 1 to 2 it is 3. Okay, 3 certainly. And then after that, as it is not having any signal, it is only 1. Okay, so this is the thing how you will plot, and then just nothing, just join them up, right? Okay, let me figure out one thing. Sorry, it's not the way I should do. Yeah, fine. Here, this is how you will join up. Okay, this is our resultant x3t. Okay, I hope the addition section is completely clear to you. So if you are fine with the addition, then I will be moving to the next topic, that is multiplication. Just check out the whole system, and then I will be moving to the multiplication. So let's dive into multiplication. Okay. So I will do the same for multiplication as well. Here I have, in the last time I have not taken any minus or anything, but this time I will try to take minus as well, so that you can get a clarity about it, that how does it works basically. So without further any delay, I will be just plotting with the map. Okay. So here you can see in -3 to -2, I'll be plotting with, let's say it is 0. Okay. And then certainly it will go up to 1. Okay, wait, go up to 1. This is what we have for the first signal. Let's say x1t. Okay. I'm writing x1t. Okay. Then after, for the second signal, we are having like -3, right? So minus, let's take a, okay. So this is our signal 2. Let me write it as well. X3t. Chalo. So the same way I will write that x1t is our first signal, x2t is going to be our second signal, and then x3t comes into the play. What is x3t? X3t is nothing but x1t multiplication x2t. Okay, so now how will you do? It's the same way. You can even pause the video and try it by yourself as well, because this is the same way I'm going to do. I'm going to take one interval again, and then again I'm going to calculate in between, and then I'm going to plot it in the third way. So let's take the thing. So in between, minus means like if it is between 1 to 2, right? Then what is there between 1 to 2? It is -1 in x1. Okay, x1t is saying it is -1. Okay, and x2t is saying it is 2. Here you can see. Okay, this is done. I'm just giving you a tick. Okay, this is done. So what is going to be our x3t? X3t is going to be our -2. Okay, multiplication. Then what we are moving to when it is 0 and then less than or equals to 1. Okay. If we take this interval, then this is going to be x1t is going to be 2 and x2t is going to be 1. That means x3t is going to be our just normal 2. Okay. And if we comes to the next plot, that is our minus 1t to 0. X1t over here is what? Minus, this is here for x1t is 2. Okay. And x2t is going to be, x2t over here is minus 1. X3t is going to be obviously minus 2. Okay. And then comes with minus 2 minus 1. Okay. And how will you see here? Minus 2 minus 1. Here, this is amplitude is 1. Okay. X1t amplitude is going to be 1. Okay. And in case of this, the amplitude is going to be minus 1. Minus 1. Okay. And here comes the next plot. Minus 3 to minus 2. And if I will tell about this, here you can see it is 1. And here it is 0. Okay, sorry. This is 0, firstly. This is 0. Okay. And here it is also like minus 3 to 2. And it is going to be, x2 is going to be 2. But x3, as we say, x3 is definitely going to be 0. Okay. And now comes before this, if we will take t, which is much more less than minus 3, then obviously x3t is going to be 0 because there is nothing out of this. Chalo. So we are having all the plots. You can see the time intervals here, and these are the beautiful plots. And now we are going to just plot it. Okay. So let me take the pink pen for myself. And here you come. So let me check with this side this time. X3t is going to be minus 2. Okay. So minus 2, minus 2, minus 2. Okay. Minus 2. Minus 2. Okay. And then after this, okay, direct 2. Then again minus 2. Then we are finally having something minus 2, minus 1. This is minus 1. And then after that, 0. So just we need to do nothing but, sorry, I missed it. So here we just need to plot the graph in a proper way. So this is our resultant x3t. Okay, so this is how you will do the multiplication. I hope addition and multiplications are pretty clear. Then we will be moving. I think I should keep the lecture till here. Next time we will be starting with the scaling and shifting, right? So let's meet on the next lecture. Hope you have liked the lecture, and if you have any kind of like problem regarding the understanding of the lecture, you can Means like flood the comment box with all your doubts, and I will be there for you to clear all the doubts personally. And let's meet on the next lecture. Till then, be happy. Goodbye.